Hello! We're going to play a game that I really like, and I have not yet finished. Because once it gets more complicated, it gets a little hard to keep things straight. I've gone further than this, but I don't think this has cloud save, so well, I guess we'll use this picture. But this is Human Resource Machine. It is a great game. And let's just jump in real quick. Welcome to your first day. You look like an excellent instruction follower. Your first job will appear over there on the right side in a moment. Remember, you can always ask me for help. So, basically, I just follow instructions. My character only does these sort of things. So if I only say inbox once, outbox once, she's only going to do it one time each. So it starts off simple, and you're basically scripting her behavior. And as you keep going, you get more features like branching, labels and go-tos, and so on. It reminds me a lot of coding in assembly. Actually, let's go here. So, let's say I copy that. I'm gonna have to open up a text editor. Where desktop capture? You can see that here. That's, you can't really tell that that's very assembly looking, but when we're in a further level, we will. So, let's keep going. The first bunch of these are going to be pretty easy, but if you've... I don't know how well non-programmers play this game, because I think it takes a certain type of mentality to do, especially the later levels, but if you're new to computer science topics, it could be a good way to kind of get that practice. But, okay, so now we still have to input, output everything in here, over here. But now, instead of having to go inbox, outbox, inbox, outbox, inbox, outbox, and so on, we have a jump. So if you have programmed in like a more modern language, you have loops, but assembly, at least the one that I used, I don't know how different assembly is on different things, has a jump. So you would use it to jump back to a certain line of code. And I can adjust this so we can see how that works. And it shows you the little pointer of where it is in the code here. And as we go, there you get like bonuses for fewest instructions or fewest run time or something. Okay, so we're not working with these right now. Now they're introducing basically kind of like registers. So we have 0 through 5. We have 6 locations of memory we can store. Right now, we're ignoring the outbox. We are able to copy from a register, and we specifically want to output bug. So copy from U next. Output that. Copy from G next, and outbox. And she'll do that. So accessing specific parts of memory, basically. So this, it gets pretty in-depth pretty fast. Okay, so here we need the first 2 things from the inbox and put them in the outbox in reverse order. So we can't just go inbox, inbox, outbox, or anything like that. That's not going to work because she's just going to throw away whatever she has. Here, let's just step that. If she has something in her hands, she's going to just throw it away when she does another inbox. We have to be able to manipulate that properly. So grab the first thing. We're going to copy that value just here. We don't really care. We're going to copy the second thing. And so we're going to put that second thing in the outbox here. And we need to grab that old value here and put that in the outbox. I'll have labels here in a little bit. But that may make it a little bit cleaner, but see, we'll step through this. She grabs something from the inbox, we're going to put it in the outbox, we have 4 and 5, so we need to output 5 and then 4. So we're backing this up for later. We'll grab 5. We'll just put that directly over there. There's no reason to store it in memory. We'll grab that 4. We'll throw that in there. So now instead of 4, 5, it's 5, 4. If you're thinking of, you know, getting to the output first. And since there's a jump, she'll just keep doing that for each of these. And actually, let me go ahead and copy this. Let's see if that's a little bit more interesting looking. So here we have A, label A, inbox, copy to position 0, inbox, outbox, blah blah blah, jump back to A, label A. So, yeah, let's just keep going. And now we have a cutscene. There's also a sequel to this game, which I also have not completed, but I've played both of these close to the end. The only problem with the sequel is if you put it down for a while, it can be hard to remember how to play it. This one is pretty straightforward for me, at least. But the second one is also very cool. I like it a lot. Okay, so how many of these... It's not super terribly long. There's also bonus things here. Let's just go into here. Rainy summer. So, for each 2 things in the inbox, add them together and put the result in the outbox. You have the command add, so we've gotten one little math operation. So we're going to need to grab something from the inbox. We can't just say add from the next thing in the inbox. We're going to have to store that in memory. Grab the next thing from the inbox, and then add that to the thing we stored, and output it. So we'll step through this real quick. Grab that first thing, copy... Oh, oops, I meant copy to, not copy from. Okay, let's try that again. Grab something from the input, save it, grab the next item, add these 2 together, just throw that right in the output, and repeat that over and over. Okay, so I'm going to do this one, but I'm probably not going to mess with these because there's plenty of puzzling to be had here. So, this one is we need to grab something and triple it and output the triple. However, we only have add, but if you can think about how like 3 times 2 works, that means 3 plus 3. Or, let's say, 3 times 4 is 3 plus 3 plus 3 plus 3. You're adding 3 to itself 4 times. That's 3 times 4. So we're going to take something, put it back in that first area. So we have, let's say, 4. We're going to triple it, so we need times 3. So we're going to add to itself. Let's just add twice and output, and make sure that works right. So 4, add it again. 8, add again. 12. And then that will go to the outbox. So then that triples it. We don't have access to multiplication, which is also true of the assembly that I've used. Again, I don't know how fancy they make assemblies, but I just used MIPS when I was in college. So you just have to kind of figure this stuff out. And we have no branches for if 0 at the moment. Just output the 0, but that's okay. See, there's a size challenge, how many commands, and how many steps it executes on average. Okay, so we could keep doing that. We're not going to do that. This is another good level. So here, we're reading stuff from the input, and things that are 0 are basically the ends of the sentence. So we're using a null terminator, just like you would do in C. where you have like just some amount of space in memory. You don't know how long the word is going to be, so you kind of overestimate it. And to mark the end of your sentence or whatever, you put a null terminator. So in this case, it'll be a 0. So let's see. We have a jump if 0 and jump, so we need to read in, send everything that's not 0 to the outbox. So we just read in one thing. If it's 0, we're gonna just go grab the next thing in the inbox. We don't care. Otherwise, it's gonna skip this part if it's not 0. So it'll come down here, it'll put it in the outbox, and we need to keep repeating that over and over. So I think these visuals are nice, but this is kind of where I get tripped up once things get really complicated, because it can be hard to keep track of your entire program. So we're just throwing stuff out there. Zero preservation. Okay, send only zeros to the outbox. So this time we grab something. If it is 0, let's say, if it is 0, it's going to jump over here. It's a little bit hard to see it, but basically, if it's not 0, it'll do this. If it is 0, oops, sorry. We want it in the outbox because we're saving the zeros. If it's not 0, we're going to reset and come back here. If it is 0, we're going to come over here and output it. I'm not sure if there's like a nicer way to organize this. This is just kind of how I think about things. And of course, once we're done outputting our 0, we need to repeat the entire program again. So that's a 0, throw it in the outbox, jump back to the beginning, not a 0, not a 0, and so on. Speed that up. Yay! Okay, so I could have done this in fewer steps. Probably just better usage of my jumps. So we can also clear this, grab from the inbox. It's going to go in the outbox. If it's 0, I don't know. Yeah, I'm not sure how to just organize that to be better. Whatever. I don't care. I'm not going to perfect run this. Subtraction? Never learned that in school, did you? So now we have addition and subtraction. For each 2 things in the inbox, subtract the first item from the second item and put the result in the outbox. Then subtract the second item from the first item and put that result in the outbox. Then repeat. So in this case, let's just kind of do this intuitively. I would like to grab the first thing, put it in position, let's just put it in position 1, I guess. Grab the second thing, put that in position 2. This is not going to be the most efficient set of code. I'm just trying to make it more intuitive here. So we're going to grab item number 1 and subtract item number 2. That's our first step. Throw that in the outbox. We're going to grab item number 2 and subtract item number 1 and then throw that in the outbox and then repeat everything. So I could reduce the amount of code steps here, but I tend to like to write my code to be easy to read and clear on what it's doing, rather than making it like the most clever thing. Did I do it backwards? Maybe it's copy from, what are we doing? Subtract first from, okay, so I have this backwards. Copy from 2, subtract 1, copy from 1, subtract 2. So, grab the 7, and now we're grab 7. See, I didn't need to grab that a second time, but in this case, I think it just makes it a little bit clearer. I can remove that, you know, you could optimize it after the fact. You can refactor your code. So we'll just speed this up. we go. Yay, so 44 steps, 11 commands instead of 10. Okay, we're gonna stop at the next coffee break, so let's go ahead and go to the equalization room. How can we know what is bigger than the other number? So, oh, now we have labels, yay. Get 2 things from the inbox. If they are equal, put one of them in the outbox. Discard non-equal pairs. So let's go ahead and just do the obvious again. Grab 2 things, store them in memory, even though we don't necessarily need to store them in memory. We don't need to store both of them in memory, but I'm going to just to make it more clear. So grab both of those. How do we tell if they're equal? Well, if you take 5 and you subtract it from 5 and it's 0, that means they were the same thing. So if it is 0, we are going to output that item. Or nope, not quite. We need the original because we're going to be holding the subtracted value. Grab that original value and throw it out into the outbox. And then jump back. So if it's not 0, we're going to reset. Otherwise, we're going to continue on with this and reset. So let's just step through it. Grab that. We'll do slow. I keep doing the wrong one. Copy to. Copy to 1. Okay. Grab 9. Put it there. Grab 5. Put it there. We're going to subtract them. It is not 0. Those are not the same number. Put a 1 there. Put a 1 there. Subtract them. That is 0. Grab that 1 again and throw that out. We don't want to put 0 on the output, so we have to pull it back out of memory. So still, again, more steps than I need and stuff, but that's just me. There's been a change of plans! All numbers equally is no longer profitable. Big numbers only. Grab 2 things from the inbox and put only the bigger of the 2 outbox. If they are equal, just pick one. Repeat. So now we have jump if negative. So again, let's copy 1 item there, 1 item there. If we subtract item number 1 from item number 0, if we get a positive value, the first number was greater. If we get a negative value, the second number was greater. So let's start adding let's start adding comments. So we have 0 and 1. I'm just trying to think of how to not make this weird. So let's say in subs, are we doing in sub 1? Copy to 1. In sub 1 minus in sub 0 is less than 0. And then in here it's in sub 1 minus in sub 0 is either greater than or equal to 0. Because the opposite of less than is going to be the greater than or equal to. We don't know if it's negative or not. I'm sorry, positive or equal to. Are they the same number? Are they different? We just know that it was not negative. So let's just work through this a little bit at a time. We take 1, we subtract 0. Let's say if it's negative, we do this. Let's put this here and adjust this so that, oh, can I not erase this part? In sub 1 minus in sub 0 is greater than 0. And then down here, in sub 1 minus in sub 0 is equal to 0. Okay, so this is where those jumps get all gross. If it's 0, it's going to run this thing. If it's negative, it's going to run this thing, and we're going to need some extra jumps, and it's a mess, but it could be cleaned up. So we're grabbing the bigger one. let's, in sub 1 is gonna be the bigger one. I'm getting mixed up with those. Let's just work on trying to copy the correct value. And if it's this, it doesn't matter which one we take because they're both the same. So this step is really kind of redundant, but I'm just trying to lay it out. So let's look at this and make sure we have the logic right. So 4 and 2. Now do 2 minus 4. It's negative. Let me pause. That was not what I wanted. So I grabbed the wrong one. It was negative. I copied from 1. So do 2 and 5. 5 minus 2 is 3, so grab the 5, put it out there. Oops, I forgot my jumps. We want to stop doing what we're doing and restart after each of these. So I'm gonna have to put these jumps here, and there's already a jump there. Not the cleanest, not the greatest, but we'll see. Let's do 8 and 6. It's negative 2. Oh, I missed a step. Did it not grab that? I might have to rearrange those. Oh. Well, that happened to work out. I wasn't thinking about negative numbers. Oh, she totally skipped that 8. Okay. I might have to clean these up. This is bad. So we have, man, I hate these jumps so much. Okay. We're gonna take that value, subtract that value. If we have a value that is negative, that goes there. And we copy from there in the outbox. I'm going to get rid of that because that's redundant, because if it's greater than or equal to 0, it should just do the same thing anyway. And then we need to jump. I'm going to make this jump to the end before it jumps to the beginning. Let's just see if that does what I think it's supposed to do. So 6, 7... That's gonna give us that copy from number 1. Throw that out. And restart. I want it to give us... Okay, she just like completely forgot that one. So I can actually step back a little bit. So what did she do? She got a negative 5. Oops. Let's try that again. So we already know that one's okay. I am not confident in those negative numbers. Putting that one out there. 5 and negative 5. That'll give us 0. Or no, negative 10. Okay, well that worked out. I'm not certain that that would always work because of those negative numbers. Okay, let's watch this cutscene and then we are gonna stop it for now.
And that, ladies, is how I saved a bundle on my long-distance telephone service. Back to work, everyone.
God, I fucking hate offices.
A massive army of machines has surrounded the city. The machines are not moving, and they are not communicating. Local authorities are investigating.
Like, I freaking hate break rooms, you know? Like, I don't like any of it. I don't like any of it. Okay. So, let's look at some more of these later on. But for now, I need a break. Thank you for watching.